Hello everyone. Today we're going to embark on a fascinating journey through the history of electricity, a force so fundamental to our modern lives that it's hard to imagine a world without it. From the mysterious spark of static electricity observed by ancient civilizations to the complex electrical grids powering entire cities today, the story of electricity is one of discovery, innovation, and transformation. Let's begin by stepping back to ancient times. The earliest known experiments with electricity date back over 1,600 years. Around 600 BC, the Greek philosopher Thales of Miletus discovered that when amber was rubbed with fur, it could attract lightweight objects like feathers. This was the first recorded observation of what we now know as static electricity. However, for centuries, this phenomenon remained a mere curiosity with no practical application. Fast forward to the 16th century when William Gilbert, an English physician and scientist, made significant contributions to our understanding of electricity. In 1600, he coined the term electricus, from the Greek word for amber, electron. Gilbert distinguished between magnetism and electricity, laying the groundwork for future explorations. In the centuries that followed, scientists continued to experiment with electricity, but it wasn't until the 18th century that major breakthroughs began to occur. One of the most famous figures in the history of electricity is Benjamin Franklin. In the mid-1700s, Franklin conducted a series of experiments that demonstrated the link between lightning and electricity. His most famous experiment involved flying a kite during a thunderstorm, which allowed him to capture an electric charge using a metal key. This experiment proved that lightning was a form of electricity and led to the invention of the lightning rod, a device still used today to protect buildings from lightning strikes. While Franklin's work was groundbreaking, the 18th century also saw another key development in the understanding of electricity: the study of electrical conduction. In 1729, Stephen Gray, an English experimenter, discovered that certain materials could conduct electricity while others could not. This concept of conductors and insulators was crucial for later developments in electrical technology. As we move into the 19th century, the pace of discovery quickened dramatically. The first major breakthrough came from Alessandro Volta, an Italian physicist who, in 1800, invented the first true battery, known as the voltaic pile. Volta's battery was a simple device made of alternating layers of zinc and copper, separated by pieces of cardboard soaked in salt water. When connected by a wire, this stack of metals produced a steady flow of electric current. Volta's invention was revolutionary. It provided a continuous source of electricity, unlike the brief bursts of static electricity generated by earlier experiments. Volta's work laid the foundation for further advances in electrical science, particularly in the field of electromagnetism. One of the most significant figures in this area was Michael Faraday, a British scientist whose experiments in the 1820s and 1830s transformed our understanding of electricity. Faraday discovered that a changing magnetic field could induce an electric current in a conductor, a phenomenon known as electromagnetic induction. This discovery was pivotal because it led to the development of electric generators, which convert mechanical energy into electrical energy, a principle still used in power plants today. Faraday's work also led to the invention of the electric motor, which converts electrical energy into mechanical motion. This was another milestone in the history of electricity, enabling the development of countless devices and machines that rely on electric power. As the 19th century progressed, the practical applications of electricity began to take shape. In 1879, Thomas Edison, an American inventor, developed the first commercially viable incandescent light bulb. Although Edison wasn't the first to invent the light bulb, his design was the most practical and long-lasting at the time. Edison's invention wasn't just about creating light. It was about creating an entire system for generating, distributing, and using electricity. He established the first electric power station in New York City in 1882, providing electricity to homes and businesses in the area. This marked the beginning of the electrification of cities, which would soon spread across the world. Edison's contributions to electricity were monumental, but he wasn't working in isolation. Across the Atlantic, another brilliant inventor, Nikola Tesla, was developing his own ideas about electricity. Tesla's work focused on alternating current, AC, a different approach from Edison's direct current, DC. AC electricity could be transmitted over much longer distances than DC, making it more suitable for powering large cities and regions. Tesla's innovations in AC technology led to the development of transformers and other equipment essential for long-distance power transmission. The rivalry between Edison and Tesla, often referred to as the War of Currents, was a significant chapter in the history of electricity. While Edison was a strong proponent of DC power, Tesla's AC system eventually won out due to its greater efficiency and practicality. This victory was solidified when George Westinghouse, an industrialist and supporter of Tesla's AC system, won the contract to supply power for the 1893 World's Columbian Exposition in Chicago. The successful demonstration of AC power at the exposition helped to establish it as the standard for electrical distribution worldwide. As the 20th century dawned, electricity was rapidly transforming the world. The development of electrical grids allowed power to be distributed across vast areas, bringing electricity to homes, factories, and businesses. The electrification of industries led to increased productivity and the birth of new technologies, while the widespread availability of electric light extended the hours of the day, changing the way people lived and worked. The 20th century also saw significant advances in electrical science and engineering. The discovery of the electron by J.J. Thomson in 1897 provided a deeper understanding of the nature of electricity at the atomic level. This discovery was followed by the development of quantum mechanics and the study of semiconductors, which paved the way for the invention of the transistor in 1947. The transistor revolutionized electronics, leading to the development of computers, smartphones, and virtually every modern electronic device. Another key development in the history of electricity was the invention of the integrated circuit in 1958 by Jack Kilby and Robert Noyce. The integrated circuit, or microchip, made it possible to pack thousands and eventually millions of transistors onto a single piece of silicon, enabling the creation of powerful, compact electronic devices. This invention was crucial for the development of modern computing and telecommunications. As we move into the 21st century, the story of electricity continues to evolve. The growing demand for energy, coupled with concerns about environmental sustainability, has led to the development of new methods of generating electricity. Renewable energy sources like solar, wind, and hydroelectric power are becoming increasingly important as we seek to reduce our reliance on fossil fuels. Advances in battery technology and energy storage are also helping to make renewable energy more practical and reliable. Today, electricity is an integral part of our lives, powering everything from our homes and workplaces to our vehicles and communication systems. It's hard to imagine a world without it, yet it's important to remember that the widespread use of electricity is a relatively recent development in human history. The journey from Thales of Miletus rubbing amber with fur to the complex electrical systems we rely on today is a testament to human ingenuity and the relentless pursuit of knowledge. As we look to the future, the challenges and opportunities in the field of electricity are immense. We face the task of meeting the world's growing energy needs while minimizing the impact on our planet. The development of smart grids, advances in renewable energy, and innovations in energy efficiency will all play a crucial role in shaping the future of electricity. In conclusion, the history of electricity is a story of discovery, innovation, and transformation. It's a story that has profoundly shaped the world we live in today and will continue to shape the world of tomorrow. As we continue to explore new ways to harness and use this incredible force, we honor the legacy of the scientists, inventors, and engineers who have paved the way for a brighter, more connected future. Thank you for joining me on this journey through the history of electricity. I hope it has given you a deeper appreciation for the power that drives our modern world and the remarkable journey that brought us here. Thanks for watching. Subscribe to the channel, like, comment, and share.